Well, good morning here in San Francisco.
Yeah.
What about in Madrid?
Good afternoon. It's sunny today, at least.
This is going to be an amazing day because this afternoon we have here our event. Do you know about that? Our Power
Yeah.
Electronic meetup?
Yeah. Do we have any attendee in this webinar who is going to attend
Maybe it's too early.
the yeah. But you are
But yeah,
awake.
oh, maybe there is somebody. I haven't seen who is right now connected, but maybe there is somebody coming. Well, I'm happy that yesterday a few other friends that told me that they are coming, and I think it's gonna be amazing. Listen, the people from Stanford. So yeah, I think it's amazing. So, are you following the finals of the NBA, or
No.
just focus on, or just
You
enjoying
said,
the
uh,
victory of Alcaraz in Roland Garros?
yeah, that's the key in Spain. For these days, it's only tennis here in Spain. But
Okay,
what
so let
about
me update you.
NBA?
The NBA finals are very, very interesting. So right now are let's say are playing the Pacers against uh, the Thunders, and the results are right now 1-1. And today they played the third game. So first game was won by the Pacers from Indiana, and then the second one by Oklahoma, the Thunders. So it's very, very interesting. So all my basketball supporters friends are following very closely.
But you said the Thunders are going to win this year.
Well, but the Pacers started very strong. So I think that I don't know exactly who's going to be more chances. Okay, so as we don't like to keep the people too much time in this webinar, maybe we should jump to. Do we have too much content today?
Yeah, I'm going to share the screen.
Okay, so let's start with our presentation today. So so today I'm going to do some small demonstration about this 600-watt crazy full bridge. But before that, we have some announcements. Ellie, can you move to the outline of the presentation? Next slide.
Yeah.
So we have important things today. So the first thing is presenting the community. So the community, let's say there are two parts there that you will see. This community is a way to support all the people that is designing power converters using our tools or other tools, but at the end of the day, something that if you need support, this is where we will be giving that kind of support. Then some pricing and also I think the demo and just talking about what is going to happen next week. So let's go.
Yeah. First, I think it's good to introduce the difference between Frenetic AI and Frenetic Simulator, Chema, because not everybody distinguish very easily the difference between these two tools. I know the intention is to use in a whole pack, but I think to start, I think it's better to introduce a little bit.
Of course. So every time we made these webinars are trying to explain because still is not 100% clear for some people in the audience. So it's like we have these two products. The product one, let's say Frenetic AI, is our assistant for designing power converters. So this tool is going to help you to design the whole power converter, do complete tasks like generate a project for Frenetic Simulator or generate an LTS spice. And actually, we are launching very soon Plex, designing a planar transformer. So there are a lot of kind of things that this tool can do automatically. And then we have Frenetic Simulator, that is our simulator for magnetics when you need to go deeper in the details. So when you have or you need the ability to chain details in the design of a magnetic component. So if you are an expert or not, it doesn't matter because the tool is very intuitive. But when you need to make changes, and maybe you need a sample. So if you go to Frenetic Simulator and you need a sample of a magnetic, that would be an option also for you. So today you will see both tools in our demonstration.
Good. Okay, and yes, now we have news for you because maybe most of you were in the latest webinars when we did a poll about if we're interested to explore a community for us to get all the information, all the news, all the updates, and obviously all the special offers for everybody. And that's why we have created two new things. The first one is our design library. I'm sharing the URL with you, so you can start trying to open this link. But I'm going to share the link in the chat in a couple of minutes. It's a library where you can register, create your account. You can search any kind of power electronic design, including not only converters, also magnetic design. You can upload your own design and share with other people. To share any design, you don't need to be registered.
Ellie, if you want, just to, because we are running a little bit in the limit of
Yeah.
time, since I will share the designs later, maybe I can also show the details. But yeah, as Ellie is showing right now, this is actually the the community. So you can tell us or tell the people what kind of designs or examples you need to see, and let's say the people can upload their own designs or you can upload your own designs, and also we will be uploading designs as an example. So so you will see um, a lot of problems solved here for those
Yeah.
cases that are not very obvious.
Okay. And why we have said you can request a design if it's not yet in the Frenetic library, because we have created the WhatsApp special community of power electronics by Frenetic. And this is the QR you can scan with your mobile phone. So you can get into the community and you can access special discount offers. We are going to share special polls to know your feedback regarding Frenetic AI and Frenetic Simulator. And maybe we are going to create some groups about discussion with our engineers. I think it's a good platform to get communication between us, not only in the webinars.
Let's say we have created this community, and the main reason is that since we launched Frenetic AI, we have seen a lot of, let's say, basically Ellie and Letty, they spend 5 hours a day answering emails, and still we will keep answering those emails. But I think that there is a lot of people that is just looking for some more support that can be held by the community. So I think that here is a good way to learn more about your needs, but also offering a special sessions for the community. So
Yeah.
internally, we have a lot of resources that we have been creating over the years, and we will start putting those resources in the community. So if you are in the community, you will receive, let's say, you can download for free sometimes PDF or presentations from previous years or documents, internal documents we have created for the lab. So it could be more under request about, okay, the people is asking for this topic, so we will try to solve it with sharing a lot of, let's say, valuable documentation. So we really invite you to join us in the community.
Okay.
Okay, and now
Let's go.
let's go. So let me share my screen now.
Okay.
So, one of the most interesting things about working with, let's say, with topologies or analyzing which topology is the most feasible or the most interesting for a specific case is understanding about the ranges. And today, something I'm going to review is how to design this phase shift. Well, I choose the phase shift full bridge in this application because actually I have been working in a very similar application where we made the analysis and it realized that when you're working in a range like this one that is from 180 volts to 350 volts of input voltage, and actually in the output voltage we have a range of, I mean, it's supposed to be 48 volts, but in the transients we can go from 39 to 52. Um, this is very similar to some Vicor models that actually are like 700 bucks each model. And let's say the maximum power is 600 watt. And the interesting thing here is that how you make the analysis for the whole range and also let's say, how you keep the output voltage of 48 volts in a full bridge phase shift when you have this range. So this is what we are going to do here today. So let me jump directly to Frenetic AI. So if you register a Frenetic AI, so for example, if you can, this is for free here. So you can come here, our website, and click try for free, and then you will be in this page. So you can register and use it. There are some limitations in terms of credits for the free license. You will see in the plans later. But the interesting thing here is like, okay, you can say, let's design this full grid phase shift. So you choose the topology, and then you can just type the input. And this is where the magic starts. So there is not a specific way to write here. So you can write even in Spanish, you know.
Mhm.
You know, you can write whatever you want, and then you type also the output voltage and the output power. And since we don't have much time today, this will take around 1 or 2 minutes. So I ran this before. So when you click here, what you are going to see is something like this. So the system is going to generate the complete design. So in this case, it has chosen automatically 100 kilohertz for the design, and you can see here the interesting point. So for the limits, the system calculate the data cycle you need for getting the 48 volts in the output, and also will the, let's say, the in radians, the output voltage, and also calculate what is the tune ratio that is going to allow you to work in the whole range. Then the magnetizing inductance and the output inductance for keeping, let's say, usually this is fixed to 20% or 25% of output current ripple. Then you just click on design the magnetic and you will get here the magnetic design. This is a transformer where the system chose PQ3235. So what I'm going to do is download the LTS files. So if I download the LTS files, I will have this complete design here in LTS files. So let's give a few seconds. And let's see if we can generate. And once we have that design, what we are going to verify and play with is with the, so there we go. So now I download. This is the download phase. So here I have the file. So you can see here, this is the file generated by Frenetic AI. So you can see that there is a transformer, a put inductor. Right now, we are still here with ideal components. That's something that we will be adding more details in the near future. And I can run this simulation. So in this simulation, what I can tell you is that in this case, we can see that in the output is, well, is totally 47 volts. I mean, we need some adjustments for 48, but let's keep this as a is okay. And if I come here to the simulation, um, you can see in the part of PWM parameters, that is cycle. So you can see that it's 0.7. So yeah, I come here, I can see that the system generated the simulation and the first operating point generated is 180 volts and 70%. So if I come here and say like, okay, now I'm going to test what's happened in the other point, in the maximum voltage. So you just click in this parameter. You just change that parameter from 0.7 to 0.36. That actually is the parameter, is the value of the 36% with the voltage 350 volts. And and also I need to change the input voltage. Is right here. I will keep the same output power, let's say, yeah, output the load, because I just want to change the range of the input voltage. And then I can run again, and I can see if the things are still working or not. So right now we can see, well, now it's 46.5, so we are losing something in the way, so we will need to adjust a little bit the voltage to have the 48, but still we are pretty close to our, let's say, inside of our limits. And as you can see, this is the way to control, let's say, to modulate a phase shift converter. And in this simulation, it's extremely easy because basically you have here the values. And if you want to have more values here, you just need to specify here the value you want. So you can just say, I want to specify 200 volts, and you will get the data cycle, or you can generate that values for your case. And but this is not all. So right now we have the simulation, and we have the, let's say, the analysis of the simulation for the full range. Um, but what about the transformer? So the transformer here is having 4 watts of losses, maximum temperature 82 degrees. So what this tool is going to do now automatically is to generate a project in Frenetic Simulator. So what that means is that it creates the complete system. It fulfills all the, let's say, the data and all the information you need to keep playing with the magnetic or to make adjustments. So if we come here, we can see that it chosen the same core, this PQ32, 35, 3C95. Um, Also, we can see that the position of the wires is exactly the same. We can check the leakage inductance here, 0.6. We can check the core losses and everything. And now what we are going to do is the important analysis for the range. So this is considering the maximum voltage. Okay. So now what we are going to do is to start adding more operating conditions like minimum input voltage, and nominal input voltage. Actually, I'm going to name this just to make sure we understand what we're doing. This is in non. This is the in min, and this is min max. I'm going to make sure that we run the simulation here. And also here. And now we have run the simulations in the 3 points. So what I'm going to do is to show the 3 points here in this report. So what we can see is that this design is pretty stable for all the range. So the maximum temperature of the component is kind of very stable, 81, 82 degrees for the 3 cases. Total losses also are very stable, so not affected that much for that. And most of the changes are in the, let's say, actually it's a combination of core and winding losses. But let's say that now you also want to play with the power level, so you keep adding points and you can start playing with the lower, let's say, lower cases, or decreasing the or just analyzing a different operating condition. And that's all for this explanation. I will get this. I will leave a space for some questions. Before jumping to the questions, again, this is the library. So the way that it works is very simple. So you can here, you can create an account. It's very just straightforward. Just email and password and upload your designs. These are kind of some of the designs that people or friends have already updated. And you can just search here. So if, for example, you are looking for a PFC, you just write here PFC and you can see PFC. And if you filter by magnetics, then you will get the magnetics. If you are looking for a PFC power supply, so in this case, there is no PFC. So be the first one to upload a PFC design of a power supply. So it's very easy. And the way to upload once you have an account is just clicking here and upload new design. And this is a very interesting way to show the rest of the community, or even to share with your friends and people what you are able to do. And yeah, for example, here we have a flyback with Plex, or yeah, we have a lot of stuff here that it could be interesting. And that's all from my side. I don't know if there are technical questions, or before
Yeah,
jumping to you.
we have some questions. Can the tool export model to Simulink MATLAB?
So, uh, so the technology now is going to generate LTSpice and Plex. So not Simulink MATLAB. But if this is something interesting for you guys, we will try to create the files as well. So for us, it's not, let's say, it's more about how many people is going to use that. So if Simulink MATLAB is a good option, let's say, let's do it. There is also about the tool predicting interwinding capacitance. I love that somebody is asking that, because we already have our interwinding capacitance model have been tested. It took us a lot of months of work, very intensive work, and working also with finite element analysis simulations to verify in the lab and everything. And it's something we are integrating right now. So I don't have a specific date because it's something happening right now, but we are including the interwinding capacitance. Okay, somebody is asking, computer screen is not shared.
Leakage issues is asking the chat. How about leakage issues?
I mean, I don't know. I mean, I guess that is supposed to say leakage inductance. What is something I saw during the presentation about in the transformers. You can see the leakage. If this is the, let's say, the point. Um. Okay. So
Do
do
we
you want?
have 1 minute to explain? Because I have some questions regarding the pricing of Frenetic AI.
Yeah,
Don't
maybe you
know.
can share the pricing before the
Yeah,
people need to leave.
yeah. You can register for free the hobby license. It's totally free. Of course, with up to 5 credits, you can design the converter and see the magnetic specs and download the LTS Spice file. And for now, there is the pro license.
Is enough for a person to join more than, or to test more than 200 designs in a month, but
Yeah.
there are some limits in the credit. So if
So
somebody is doing more than that, they will need to grade, but it's almost like unlimited.
I think it's enough to more than 2,000 of.
But there are
But
crazy people.
it's good to remember everybody that the free license includes 24 hours of magnetic simulator access, so you can try the whole experience. And if you if you upgrade to the Pro license, you can use for 7 days. So this is more if you need to test during more time the both tools.
And if you
And
move to the annual pro, also these 7 days can be extended to a month. So
yeah,
it's like a very interesting way to test the whole experience.
yeah, and that's the key question, Chema, because some people after experience the Pro license wants to upgrade to continue using the magnetic simulator, and that's why this is the perfect pack for them.
I think that today we are a little bit out of time. So
Yeah.
thank you very much, everybody, for being here. As always, you have our email and our contacts to any question, anything you have about uh, the the plans, about what we have explained today. Also, join us in the community. Propose us more topics you want us to talk next week. So yeah, thank you very much for coming.